Hello everyone! Welcome to our third lesson of our online math class. So today we're going to simplify exponential expression with zero, positive, or negative exponents. Okay, now I have here a QR code where you can scan it with your phone, okay, and you will arrive at this link and you can download it, print it, and then write down your notes here. So for today's lesson, it's a lot, and if you can print it, then it's nice. Okay, you can just write it down and then take a picture once you're finished and then send it to our Google Classroom, or you can write down if you have your iPods with you or some pads. Okay, you can write it down and then you can send your notes for our grading. Okay, it's part of your grading system that you have your own notes with you. Okay, so that also you can review when you need it. Okay, now today's lesson, we will focus on zero, positive, and negative exponents. All right. Now we have objectives here. We have two, and at the end of the lesson, you're expected to review how to multiply and divide exponential expression with the same basis. And number two, simplify exponential expression with zero, positive, or negative exponents. Okay, so now we will move on to our lesson. Okay, now our vocabs is a little bit more compared our second lesson, I think. Yeah. Okay, we have add, subtract, multiply, divide, expand, zero, reciprocal. Okay, again, add, subtract, multiply, divide, expand, zero, reciprocal. Reciprocal. Okay, remember that word. Okay, we will use that in M3 as well, reciprocal. All right, so remember our concept number one is we add the exponents when we multiply exponential expression with the same base. Again, we add the exponents when we multiply exponential expression with the same base. Last time I asked you to make a video of you explaining yourself about this rule, okay, and also the second rule. Now for the second rule, or concept, we subtract the exponents when we divide exponential expressions with the same base. All right, now let's review. Okay, if you remember, if they have the same base, it's easy to simplify. Now it's multiplication here. Okay, so you have to add the exponents. So 5 plus 8 is equal to 13. Okay, so number 2. Okay, so number 2 is a bit tricky because you have your x squared y cubed squared. X squared y cubed. Nothing. Okay, it means to say that there's a 1 here. Okay, don't be scared of numbers. Okay, you have what it takes to make it possible. Now you have here exponents as 2. Your exponent here is 1, so 2 plus 1, which is equal to x squared y cubed to the power of 3. Now maybe you think, Teacher David, can we simplify this further? Yes, but not in this lesson. Okay, in the following lesson you can expand this further. All right, so let's look at number 3. We have 5 to the power of 6 divided by 5 to the power of 2. Now this is divide, so we subtract, minus the two exponents. All right, so 6 minus 2 plus 4. All right, and we have 24 to the power of 3 divided by 4m. Now when you encounter this question, okay, we change the question into a fractional form, right? So it's easier to simplify. 24 divided by 4 is equal to 6. You have m3, or m to the power 3, minus 1, and you will arrive at the answer of 6m squared. Okay, so you can look at the questions here, and if you need to check out your understanding, you can look or you can watch the second video for that lesson. Okay, for example number or concept number 3. Okay, now we have the part, the question part. Okay, what happens to the exponential expression when the exponent is 0? Is it the same as like the question? Is it a to the power of 0 equal to a to the power of 0? Right? Yeah or no? Okay, so that's what we're going to check out today. All right, now we will move on to our first investigation. Now, remember our FEP acronym: fixed, fix, expand, process. Now, let's say, for example, you have 4 to the power of 2, or 4 squared divided by 4 squared. Now, when we expand this, okay, we will have 4 times 4, right, the top part here, over 4 times 4. Now we cancel this out together. Oh, what happens? 4 and 4 is 1. 4 and 4 is also 1. So it means to say this is equal to 1 when we expand it. Now, when we process this using the subtraction rule, okay, when we divide to exponential expression with the same base, we minus or subtract the exponents. 2 minus 2 is equal to 0. So let me ask you, is this side of the of our acronym expand is the same side here as the process? Yes, definitely. It means to say that the process here should arrive at this answer, 1. So it means to say that 4 to the power of 0 is equal to 1. So will this rule apply to other numbers? Let's check another one. X to the power of 3 divided by x to the power of 3, where x is not equal to 0. It cannot be equal to 0 because it's it's undefined. Okay, now let's compare our answer with expand and process. Okay, for the expand, x to the power of 3, 1, 2, 3, divided by x to the power of 3, 1, 2, 3. We cancel out the x here. The answer here will become 1. Process part tells us that if you have the same base, we subtract or minus the exponent. 3 minus 3 equals 0. Oh, so it means to say that the first example that we have here has the same result as our second example. It means to say that whether number or variable has the same result when your exponent is equal to 0. That's why when your exponent is equal to 0, the result is equal to 1. Okay, now let's have our first example. Right? Okay, maybe you can see that they have the same base, all right, and we divide them, right? So we can fix it to be okay, and you can write the whole thing down to be 1, 2, 3, 4, 5, 6, and 7. All right, or divided by 2b 1, 2, 3, 4, 5, 6, 7. Okay, all right, and you can cancel all the 2b's out together. Okay, this one, each pair will be canceled out, and the result is equal to 1. Or okay, no, for the expand, we expand it already, or we fix it. Okay, or 2b to the power of 7 minus 7, this one, 7, and 7 is equal to 2b to the power of 0. We learned already any number raised to the power of 0 except 0, the answer is equal to 1. Okay, so that's the process of mathematics. Now, very simple. X to the power of 0 equals 1. Okay, good job. Very easy. Alright, x cannot be equal to 0, by the way. Okay, now we have 11a to the power of 0. Can you see a parenthesis? No, you cannot see a parenthesis. Now, what is the exponent? The exponent is 0. What is the base? 11a, 11a. The exponent is 0. The base is only a. So it means to say that what we will do is we will separate a and 0. Oh, a to the power of 0 and 11. Now, if you're going to simplify this, all right, we don't need to expand this one out. Our answer is 11 times 1 equals 11. Very tricky, right? Again, the a here, all right, the a here, okay, is the base for the exponent 0. 11 is not, because we don't have a parenthesis. We need a parenthesis so that the base will be 11a. Again, a here is the base alone. That's why we need to separate them. So you will see that the exponent is 0, the base is a. Alright, and you simplify it simply. Now, let's have this one. Alright, it has the same pattern as the previous one. This doesn't have exponent parenthesis. So x to the power of 0. Okay, you can separate it, x to the power of 0. And 2x to the power of 0. Now, remember, any number raised to the power of 0 except 0 is equal to 1. Okay, so this will become 1 minus, this one is a whole group. You see, this one has a parenthesis. Since it's inside the parenthesis, everything here is included on the exponent. So you have 1. So 18 times 1 is 18 minus 1. So the answer here is 17. Okay. Alright, so we're done with our first concept for today. Now we will have concept number 4. Now here, what happens to the exponential expression when its exponent is a negative number? What happens to the exponential expression when its exponent is a negative number? I have here the answer. Okay, change to its reciprocal. When you say reciprocal, you have to flip. Okay, you have to flip the numerator and the denominator. So you will have b over a instead of a over b. Okay, a over b becomes b over a. Every time you have an exponent or a negative number as your exponent. All right, so let's see. All right, let's check our investigation. All right, okay. So again, we have expand and process. Now, 4 to the power of 2 divided by 4 to the power of 3. We'll expand 4 to the power of 2. 4 to the power of 2, 4 squared, is 4 times 4. 4 to the power of 3, 4 times 4 times 4. Alright, so we cancel it out. Okay, and then we will get 1 over 4. But let me ask you, what is the exponent of 4? 4 to the power of 1. Alright, now let's look at the process part. 4 to the power of 2 divided by 4 to the power of 3. Same process. Since it's divide, base are the same. 4 to the power of 2 minus 3. 2 minus 3 is equal to negative 1. If you look here, the expand part and the process part are the same number, or it's from the same problem. So it means to say 4 to the power of negative 1 is equal to 1 over 4 to the power of 1. You have to flip it. Okay? Now, I want you to look closely at the base. Okay, here's the base and the exponent. 4, 1. Now look at the reciprocal. 4, 1. No minus sign. Okay, is that clear? Now, the 4 to the power of 2, 4 to the divided by 4 to the power of 3 is 1 over 4 to the power of 1. Okay, so this is the result of simplifying 2 minus 3 exponent. Okay, let's have example number 2. So example number 2, you have b to the power of 3 divided by b to the power of 5. So we're going to investigate what happens if it's true also on variables. It's true with numbers. Will it be true with variables? Let's check. Okay, so b to the power of 3, expand it out. 1, 2, 3. b to the power of 5. Okay, b to the power of 5. 1, 2, 3, 4, 5. We cancel them out. B and B, B and B, B and B. The result is 1 over B squared. Okay, that's the result. That's the answer. Now, to the process part, b to the power of 3 divided by b to the power of 5. See, we minus or subtract the exponents if they have the same base. 3 minus 5 equals negative 2. Now, we put this one as the result. B 1 over b squared. Let's look at the base. The base is b. The exponent is 2. Let's look at the reciprocal. B 2. Oh, it works. Okay. So when you flip things, all right, when you flip things, the base here will get its original exponent, like this one. B 2. B 2. Okay, is that clear? Okay, let's figure out things out. Example number 3. Base, exponent. Now the process, 1 over base exponent. No negative sign. Okay, so 1 over 5 to the power of 2. All right, very simple. Let's look at example number 4. 7 minus 8. Base, exponent, reciprocal, base, exponent. Okay, very good. All right, now let's look at our a little bit complicated question. 19x to the power of negative 2. What is the base? What is the exponent? What is the exponent here? The exponent is negative 2. What is the base? X only, no parentheses. So when we fix this, it will become like this one. Expand? No need for expand. All right, now let's identify the base. Base, exponent. All right, so we have 19 times, okay, you flip this one, 1 over x squared. All right, so we can still simplify this. 19 times 1, 19 over x squared. All right. Okay, so let's move to our last example here. Okay, so we have negative 7 a squared b to the power of negative 4 c to the power of negative 6. Now we're going to fix this. All right, now this is the exponent, this is the base. Exponent, base, exponent, base. Okay, now negative 7 a squared, there's no negative sign, so no need to put in parentheses. Okay, we will separate b to the power of negative 4 and c to the power of negative 6. No need for expand. So we will simplify this. Right, negative 7a squared. Now, base, exponent. All right, you have to flip it. Oops. All right, so we have 1 over b to the power of 4. Base, exponent. 1 over c to the power of 6. Now we combine this together. You have negative 7a squared multiplied to 1 times 1 over b to the power of 4, c to the power of 6. Interesting, right? Okay, looks hard, but nah, you can do it. I believe you can. All right, now let's review. Okay, we add the exponents or the exponents when we multiply exponential expressions with the same base. Remember, if they have the same base and you multiply them together, just add the exponents. You learned that already. Example, concept number 2, we subtract the exponents when we divide exponential expressions with the same base. Okay. Now, our lesson today, if the exponent of an exponential expression is 0, then a to the power of 0 equals 1. Any number, except, of course, 0. Number 4, if the exponent of an exponential expression is a negative number, for example, this one, then transform the expression to its reciprocal. All right, you have to flip the expression. All right, so let's have some exercise here. All right, if you can do it on your own. You can answer it. You can press a pause button. Okay, up to you. Okay, just answer it. Okay, but if not, you can just watch the video and write this down on your notes. Okay, a little bit complicated for some problems, but it's not a big deal. Okay, we will follow the rules. Okay, the process parts. Okay, now let's look at the base. The base are the same. 2. Let's multiply. So it means, say, we have to add 3 plus 0 plus 4. So we have, change color, 2 to the power of 7. Okay, simple. All right, let's move on to number 2. Same base, negative 5, negative 5, negative 5, negative 5. So we write negative 5, and then it's all multiplied, so we add all the exponents. 2 plus 3 plus, oh, there's a minus 2 plus, or negative 2. Now, we have 2 here, and we have negative 2, so we can cancel out. So what is left is 3 plus 3. So negative 5 to the power of 3 plus 3 is equal to negative 5 to the power of 6. Remember, when the exponent is an even exponent, you can change the base to its positive form. Okay, we had an example in our, I think, lesson number 1 or 2. Yeah. Okay, so let's move on to example number, or exercise number 3. Now we have to fix this one. You see 0.5, we have 1/2, 0.5, 0.5. What we will fix, or how we will fix, we will change 1/2 into 0.5. Okay, so we will have the same base. Okay, now since we have the same base, we will add all the exponents together. 2 plus 5 plus negative 1 plus 6. So we have 2 plus 5 plus 6 is equal to 13. 13 minus 1 is equal to 12. Alright? Very easy. Okay, now for question number 4, it's a bit complicated because we have a big number here, 81. But of course, it's not impossible because we can divide 81 by 9. And then we can divide 9 by negative 3. Alright, so 81 is 9 times 9. 9 is equal to negative 3 times negative 3. Why not 3 times 3? Because all of these are negative. Okay? So we have to change this or fix this. 81 is the same as negative 3 to the power of 4. Okay, and then negative 3 to the power of 0, negative 3 to the power of negative 2, and negative 3 to the power of 2. Okay, same thing. Right, process this. We have the same base, so we have negative 3 to the power of 4 plus 0 plus negative 2 plus 2. Oh, we have negative 2 and 2. Okay, cancel this out. You will arrive at the answer of 4. Remember, it's an even exponent, so we can change it into a positive base. Even exponent leads to that number. Now we have the same problem as the previous one. 64 is a big number. So what we will do is we need to change 64 into base 2. So 64 divided by 2 is 32. 32 divided by 2, 16. 16 divided by 2, 8. 8 divided by 2, 4. 4 divided by 2, 2. 2 divided by 2, 1. How many 2's are there altogether? 1, 2, 3, 4, 5, 6. Okay, so we fix it. We write 2 to the power of 6 instead of, oops, there's 2 to the power of 6 times 2 to the power of 4 times 2 to the power of negative 3. Now we will add all of this together. Okay, so we will add all of this together to be 6 plus 4 plus negative 3. Okay, 6 plus 4 plus negative 3 is equal to 7. Okay, now that's the end of our lesson. Thank you very much for watching and hope to see you next time. Have a nice day. Have a great day. Stay safe and stay healthy.